Welcome back to our channel. Today we are looking at geometric progression. Geometric progression, what is geometric progression? When you have a sequence of numbers, let's say 5, 10, 20, and 40, and the ratio between each consecutive numbers, let's say 5, 10, 10, 20, or 20, 40 is the same, then we call that a geometric progression. For example, when you have the ratio between the first and the second number, 10 divided by 20, you find it is 2. The ratio between the third and the second number, 20 and 10, is 2. So the ratio is the same all along between each two consecutive numbers in a sequence or in a series. Then you call that a geometric progression. We will go ahead and solve our problem. We have a series of numbers 5, 10, 20, and 40, and we have been asked to find the 10th term in our series. What is the formula for finding the nth term? Finding the nth term in a geometric series. The nth term is found by the formula. If you want to find the nth term, you will have the nth term is the first term a times the ratio r raised to power nth term minus 1. Let's have a look at our case. We will have the first term is 5 times the ratio. The ratio is 2 raised to power n. N is 10 minus 1. We will have 5 times 2 raised to power 9. This will give us a value of 2560. This is the value of our nth term. In our case, the value of our 10th term in the series 5, 10, 20, and 40. Let's have a look at our second example in problems involving geometric progression. We have been asked to find the sum of the first 7 terms in this series: 0.25, 0.75, 2.25. What is the formula of finding the sum of a given terms? Let's say the nth term. If you want to find the sum of the nth term, you will have the sum of the n terms will be a into r is the ratio raised to power the nth term minus 1. Divide this by r minus 1 in case r is greater than 1. But there can be a scenario in which r might be less than 1. It will be simple. You will have the sum of the nth terms as the first term times 1 minus r raised to power n, all this over 1 minus r. This is when r is less than 1. But in our case, the value of r is greater than 1. If you have 0.75 divided by 0.2 to find the ratio between the consecutive terms, you find out that r is 3 and 3 is equally greater than 1. So we will use the first formula to find the sum of the first 7 terms in our case. Now that we have the value of a, we have the value of r, we have the value of n, we should go ahead and substitute the values in our formula such that we will have the sum of the nth term, the sum of the 7 terms as a, the first term is 0.25 multiply by the ratio r. The ratio r is 3. If you take 0.75 divided by 0.25, you find it is 3. Take 2.25 divided by 0.75, it is 3. How do you find r? You might be having problems in finding r. R is simply the ratio between each two consecutive terms in a geometric progression. For example, our first term is 0.25, our second term is 0.75. The consecutive terms 0.25 and 0.75 have a ratio of 3. If you divide 0.75 divided by 0.25, you find the answer is 3. That is the value of our r. Now you take r, 3 raised to power the 7. We are looking for the sum of the first 7 terms minus 1 you divide by 3 minus 1. Right, you will have 0.25 times 3 raised to power 7 minus 1 you will have 2187 divided by 2. When you work out all this, you will find your answer to be 273.375. 273.375. That is the sum of the first 7 terms of our series 0.25, 0.75, 2.25. Let's have a look at our third example. You can pause the video and try it out. You have been given the first term as 4. You have also been given the sixth term as 128, and then you are asked to find the 8th and the 11th term. Now, what is the formula? How do you find the nth term in a geometric series? The nth term is found by the nth term is a times r raised to power n minus 1. In our case, the nth term is 128. The sixth term, it is 128 is equals to a, the first term, 4 times r. We don't know what r is, and then it has been raised to power n minus 1. N minus 1 is 6 minus 1. That will be 128 is equals to 4 times r raised to power 5. Divide all along by 4, so you can have 32 on one side is equals to r raised to power 5. R raised to power 5 is equals to 32. Work out the fifth root of 32 to find the value of r. You will find out that r is equals to the fifth root of 32, which is 2. The value of r is 2. Now that you have r, you can go ahead and find the 8th term and the 11th term. You have r is equals to 2, you have a is equals to 4, and then you are asked to find the 8th term. That is, the value of the 8th term is equals to a, the first term a times r raised to power n minus 1. That will be the first term a, which is 4, times r, our r is 2, raised to power 8 minus 1. That is 4 times 2 raised to power 7. 2 raised to power 7 times 4 is 512. 512 is the value for our 8th term. And then we also want to find the 11th term. That is, the 11th term is a times r raised to power n minus 1. We will have our a is 4 times r is 2 raised to power n. N is 11 minus 1. We will have 4 times 2 raised to power 10. You will find the value of the 11th term to be 4096. This is the value of our 11th term in our problem. There is our fourth example. You can pause the video, try it out, and you can see what you find. Now, we have the series 4, 2, 1, and the series continues. We find the value of a in our series. The value of a is 4. the value of r is 2 divided by 4 or 1 divided by 2. Whatever consecutive numbers you choose in the geometric series will give you the value of r. Now the value of r, let's say 1 divided by 2 is 0.5 or 2 divided by 4 is 0.5. That is the value of r. Our r in this case is less than, our r is less than 1. Now what formula for sum of a geometric series will we use? We will say that the sum of the n terms is equals to a into 1 minus r raised to power n over 1 minus r. In our case, we are looking for sum of numbers up to infinity. The sum up to infinity, we will say that is a. Our value of a is 4, and we will have 1 minus r raised to power infinity. That will be r is 0.5. r is 0.5 over 1 minus 0.5. You will have 4 times 1 minus 0.5 to infinity. If you raise 0.5 to infinity, basically any number, if you raise it to any number less than 1, and any number less than 1, you raise it to infinity, you will definitely find 0. Any number less than 1 and greater than 0, you raise it to infinity, your answer is automatically 0. Now 1 minus 0 is basically 1, and then you have 0.5. We'll have 4 times 1 over 0.5. That will give you 4 times 2. 1 over 0.5 is 2, and your answer is 8. Now, if you find the sum of this geometric series 4, 2, 1 up to infinity, you find the sum up to infinity, your answer is 0. Your answer is 8, not 0. Your answer is 8. Your answer is 8. Your answer is 8. We have our third example. You have been given a series of numbers 3, 9, 27, and the list continues. Now, the value of a in our series is 3. Let's find out. The value of a is 3. The value of r in our series is 3. If you take the first and the second value, the ratio between the first and the second value is 3. If you take 9 divided by 3, it is 3. Take 27 divided by 3, it is 3. Now, the value of r is 3. The value of a is 3. And then we have been told, you have been asked that which term will be 59,049. 59,049. We know if you want to find the nth term is the value of the first term a times the ratio r raised to power n minus 1, right? Now, the nth term in our case is 59,049. 59,049 is equals to 3, which is our first term, a times r. Our r is 3 raise it to power n minus 1. We don't know the value of n, but if you take 3 times 3 raised to power that value of n minus 1, which we don't know, you find out that your answer is 59,049. Divide all by 3, and you will have, if you divide 59, you will have 19,683 is equals to 3 raised to power n minus 1. Now, if you take 3 and then 3, you raise it to power 10, 3 raised to power 9, 3 raised to power 9 will give you 19,683. That is 3 raised to power n minus 1. Okay. 9 is equals to n minus 1. N is equals to 9 plus 1, which is equals to 10. Now the value of, or the value, the term of 59,049 in our series is the 10th term. The 10th term in our series 3, 9, 27 and so on is 10th. It is the 10th term. Now you can visit our channel for arithmetic progression, combination and permutation, and many other stuffs involved in mathematics and such like stuffs. Now, thank you very much for watching these videos. I hope you have understood something. Welcome back and see you in our next video.